you hear?
Yeah, I can hear you.
Okay, thank you.
Maybe Professor Amin, maybe you can wait maybe another 2 minutes, then we can start.
Okay, thank
Professor Vera, how to call it? Besora? Professor Besora, so can you try to run your slides?
Okay. Can you see the slide?
Yes, perfect, yeah.
Okay.
Okay, Dr. Amin, so I will start the recording now. Then after that, you can start the webinar.
Recording in progress.
Professor Amin, can you hear me? Professor Amin?
Yes.
Yeah, okay, you can start right now.
Okay, thank you very much. So, very welcome to our webinar series of APFESM. And this time, one of our great scientists will present his talk to our participants, and he's Mr. Pablo Basida, from is a forestry engineer with a PhD in ecological science. And his research focuses on vegetation ecology, particularly the roles of climate, biotic interactions, and disturbances, especially wildfires, in vegetation regeneration and successional processes. These are the matter which actually very important for the world forestry management, and particularly the climate change, wildfires, and the disturbance particularly. So he is also working on the developing ecological restoration strategies for degraded environments, which in our developing world is very important, because this world is directly with the restoration process. Some of the part of the world actually, the forest is degraded and somewhere deforested as well. So the restoration forestry, particular restoration ecology, and the ways and means for restorations are very important, and he is working on with that. He's a renowned scientist in Chile, and currently he's with uh, doing his teaching with forest ecology and plant biodiversity at the Faculty of Agriculture and Natural Systems of the Pontifical Catholic University of Chile. And he served as the director of forestry engineering and forestry engineering program at that faculty as well. So we are actually welcoming Professor Dr. Pablo Becerra for his talk. Please take the mic as well. Welcome, Pablo Becerra, please. Thank you very much.
Okay, thank you. Well, let's start. Well, good evening, or good morning, or good afternoon. Well, thank you very much for inviting me to participate in this webinar. It's a pleasure to be able to show you what forestry activities in Chile are like today. Well, here are the topics I'm going to cover today. First, I will give an overview of the types of forests and their distribution within Chile, highlighting the wide variety of ecosystems of forestry interest. I will also give a very brief summary of the process of alteration, degradation, and loss of forest. Second, I will talk about the different professional opportunities in the forestry field within Chile, the various career paths that forestry engineers in Chile are currently pursuing. And finally, I will describe the opportunities to study forest sciences in Chile, whether through undergraduate or graduate programs. And I will show how at the Pontifical Catholic University of Chile, the university where I work, we have developed a forestry education program that aims to cover all types of forestry-related activities in which our students may become involved. Okay, well, here is Chile on the west of southern South America. Well, here you can see Chile has a wide variety of climates. In the north, for example, there's a desertic climate, and here on the east, along all Chile, we have a cold climate in the higher elevations of the Andes mountains. In central Chile, in the central zone of Chile, a Mediterranean type climate is present with latitudinal variation, especially in precipitation levels, and also there is an altitudinal gradient, especially in temperatures and moisture. And then from 35 degrees south, there's a temperate climate zone, a warmer area up to approximately 40 degrees south latitude, and after that, a colder area. Well, here the types of ecosystem are shown. based on vegetation classification. This classification defines 8 types of vegetation regions. Well, now let's see some characteristics of these ecosystems, starting from the south. Here, with light green color, here you can see the distribution of the Andean Patagonian forest in light green. It's a forest dominated by species of the Nothofagus genus. In general, this forest has few tree species, only 2 or 3 species, but while the forest is poor in tree species, there's a greater diversity of shrubs and herbaceous species. This is a photo of a famous national park in Chile and also famous around the world, called Torres del Paine, showing this type of forest. Farther north, but still within the same ecosystem type, around 38 south latitude, we find Araucaria forests mixed with the same 2 or 3 Nothofagus species. Well, this entire area is known for its high frequency of volcanoes, which strongly shape the landscapes, physiognomy, and influence forest succession processes in this Andean region of South Central Chile. Well, also in the far south of Chile, we can find the Patagonian steppe here with light blue. It's a vegetation type dominated by grasslands and shrub steppes, where we also find some small forest fragments composed of the same Nothofagus species. Here, this is a photo of the steppes and small fragments, and a shrubland, a shrub steppe. Then, also in southern Chile, in a still temperate and cold climate, we find a forest type known as the evergreen forest and petland region. This with color green. Named so due to the high frequency of petlands in the area, of course. And in the forested areas, we can find some conifer species, which are big trees in some cases. For example, forests like this one. This is the alerce, a big tree, native Chilean tree. Well, now moving a bit farther north, here with color blue, but still within a temperate climate zone, though in this case a slightly warmer temperate climate, we find a forest type known as the Valdivian forest, or the laurifolius forest. This forest is characterized by a high diversity of tree species, but it has very few conifers and also a low frequency of Nothofagus species. But there's a high diversity of other life forms, such as ferns, mosses, and many climbing plants, although it has a lower diversity of shrub and herbaceous species. For example, this is a sample of this forest. Well, this forest Here you can see a landscape of this forest is marked by a high presence of water courses and rivers and lakes as well. Then farther north, a different type of forest begins to develop, known as the deciduous forest region, where the influence of a Mediterranean climate starts to appear. Summers are no longer as rainy, and climate seasonality appears here with this color, light blue. And well, this area is also dominated by Nothofagus species, but now with the presence of other angiosperms. It's a mixed forest with some broadleaf tree and shrub species. Here, the diversity of shrub and herbaceous species increases again, while the diversity of ferns and mosses decreases. Well, this is a altitudinal gradient from deciduous forest here at lower altitudes to Araucaria forests at higher altitudes. Well, then in central Chile, with this color, red, the vegetation is known as the Mediterranean sclerophyllus forest, and the name is Sclerophyllus forest and shrubland region. This region is shaped by Mediterranean climate. This climate is characterized by hot, dry summers and cold winters when most of the precipitation occurs. The area is dominated by the Sclerophyllus forest, composed of various tree species, evergreen tree species. These forests are mainly found on south-facing slopes, while the north-facing slopes, which are drier habitats, are dominated by shrublands, including shrubs and cactaceae species, for example, here. Well, in this picture, you can see the contrasting vegetation between the south-facing slopes, which is a moisture habitat, and the north-facing slope. Well, moving north in Chile, we reach the desert region. The vegetation here is quite variable. The coastal areas have more plant life, in contrast to the interior zones, where there's almost no vegetation at all. For example, landscapes like this one. Well, the vegetation here is absent. However, in the southern part of this region, there are some shrublands and with woody vegetation, and in certain areas there are even remnants of forests. For example, forests like this one or this one. Today, these forests are very degraded, probably because they were the only forests in the area and the only available source of wood in the past. Now, in the higher Andean zone of northern Chile, we can find an ecosystem known as the high Andean steppe region. This type of vegetation develops at elevations above 3,000 meters above sea level and is dominated by steppes, either shrub steppes or herbaceous steppes, with a significant presence of species from the Cactaceae family, like this one or this one. And in addition, we can also find some forest fragments in this ecosystem composed of polylepis species, which are small trees that typically reach no more than 5 or 6 meters in height, and are found at elevations above 4,000 meters above sea level. Well, all these ecosystems have changed significantly over the past 500 years. Here you can see a theoretical image of forest cover in the year 1550 of the area corresponding to the Mediterranean subhumid and warm temperate climates, which originally was covered by vegetation belonging to the deciduous forest and laurifolious forest types. Well, this area feature a continuous forest that over the course of history, especially in the last 300 years, was largely cleared, mainly to establish agricultural fields and livestock pastures. And in many areas, this clearing was carried out through intentional burning, which led to a significant reduction in forest cover in the present day. Well, this is the same, or approximately the same region of Chile, and this is the main area where forestry plantations have installed in Chile. In this image, you can see how the area covered by forestry plantations in Chile has increased over the past 30 or 40 years. Here in color, this color, red or brown. Since 1986 to the present, this area has increased. However, it's important to explain that forestry plantations in Chile began to be established around the mid 20th century, primarily in areas that had already been used for agriculture for 100 or 200 years, and therefore they were areas that had been altered or cleared previously, and they lost their fertility and productivity, which determined that they were eventually abandoned and then sold to forestry companies. Just from the 70s and 80s onward, the planting of exotic tree species increased significantly in open areas. First with Pinus radiata, and then with eucalyptus, mainly Eucalyptus globulus. Well, however, it's also important to say that unfortunately in the 90s, some native forests, especially in this area, some native forests were replaced by exotic plantations, mainly Pinus radiata, firstly. Native forests were cleared to plant these exotic tree species. But fortunately, this practice lasted no more than 10 or 15 years, after which the replacement of native forests with exotic plantations began to be legally prohibited. Thus, approximately only 10% of the current forest plantation area in Chile was established directly on land where where native forests were cleared for plantation development. Well, on the other hand, although native forests in Chile have historically been used, this use has been without any form of planned management, and of course without scientific and technical knowledge. Today, only a small area of native forests is being managed with plans based on technical knowledge, and mainly by companies rather than small landowners. The main types of forests managed using silvicultural techniques are those dominated by species of the Nothofagus genus, mainly here in the south of Chile. Well, this table shows the current land use distribution in Chile. Here, I highlight the forested area, which include native forests, forestry plantations, which are only plantations with exotic tree species, and some mixed forest. In this table, it's important to note that Chile currently has nearly 15 million hectares of native forests out of a total land area of 75 million hectares. But historically, about half of Chile's territory was covered by different types of forests. In other words, the original forest cover in Chile ranged between 35 to 40 million hectares. However, today only around 15 million hectares remain. Well, on the other hand, currently Chile has approximately 3 million hectares of exotic forestry plantations. Currently, exotic species used for forestry industry are mainly Pinus radiata, Eucalyptus globulus, Eucalyptus nitens, Eucalyptus camaldulensis, and also we have some small plantations of Pseudosugam and Ciesi, Douglas fir, in the south and colder environments of Chile. And it's also important to consider other land uses that may be of forestry interest. For example, the areas covered by shrublands, mainly desert shrublands, which can also provide valuable ecosystem services relevant to forestry. Additionally, wetlands in the southern Chile should be considered, as they too offer important ecological and forestry-related benefits. Well, this entire history of land use change and human disturbances has led to a situation where much of Chile's native forest is now fragmented. We can distinguish between native forest fragments surrounded by agricultural fields or grazing pasture, like in this landscape, and others that are surrounded by exotic plantations, like this landscape or this one. In central Chile, probably the region that has lost the most forest area and where the remaining forests are also likely the most degraded. We often find landscapes like this, savannas dominated by acacia caben, with very few other tree or woody species, and grasslands dominated by exotic herbaceous species. All these acacia cavern savannas originally supported sclerophyllous forests with many tree evergreen species. In southern Chile, we can also find similar situations. For example, the Andean Patagonian forest, dominated by notified species, was heavily burned and used for cattle grazing over the past 100 years. And many of these former forest areas have now been transformed into grasslands, even often with a high presence of native herbaceous species, along with other exotic species, but where the forest has barely been able to recover. Well, now I will describe the professional activities of forestry engineers in Chile, particularly in highlighting the wide variety of career paths and daily professional tasks they undertake. Well, here I'm showing you a simple diagram that outlines the three main types of demands that today's society places on ecosystem. First, the need to use forest ecosystems to obtain various types of products or services. Second, especially in recent decades, there has been growing interest in conserving ecosystems, particularly those with a lower degree of human intervention. And third, especially in the last decade, I would say, there has been a significant interest in restoring ecosystems. Well, these three types of demands are the ones that forestry engineers in Chile are trying to address. And I believe this should apply globally as well. In summary, the professional areas of forestry engineers in Chile are mainly oriented toward five key areas. First, the sustainable production of various ecosystem services of forest ecosystems, such as timber, fruits, medicinal resources, water regulation, oxygen production, carbon capture, among others. Second, the creation and management of urban vegetation, it's important. Third, an area where the demand for forestry professionals has significantly increased in recent years is in conducting environmental impact assessments, especially within forest ecosystems. And closely related to this area is the growing legal requirement to compensate for these impacts, which in many cases involve reforestation processes. And lastly, forestry engineers have long been involved in the management of protected areas. Well, going into a bit more detail of these professional paths in Chile. First, well, silviculture and forest management in Chile can be broadly divided into two main areas. One is the silviculture of native forests. However, I would say that only since the second half of the 20th century, the silviculture of native forest in Chile has been based on scientific knowledge and management plans, leading to sustainable forest management, in theory at least. Secondly, forest management and silviculture in Chile also take place in plantations, exotic plantations. There are this is important because there are almost no plantations of native tree species for So the plantations in Chile are only with exotic species plantations for productive purposes. Only in some cases, some adult native forests are enriched by planting some native tree species, but always with. Currently, the management of plantations and the forestry companies operating exotic species plantations need to certify their products for international markets, which imply an important challenge. This challenge is tied, at least in part, to how the plantations are impacts on biodiversity. Many areas where plantations were established in places that no longer had native forests, neither within the plantation area nor nearby. And in these cases, we now can find green deserts. These areas, these are areas with little or no chance of native species recolonizing, either through dispersal or vegetative regrowth, because of the history of the use of the land use. But in contrast, in areas where plantations replaced native forests, or the plantations are located near native forests, native species often regenerated from stumps or resprouting, since many Chilean native species have the capacity for vegetative regrowth. And native species, other native species were dispersed from remnant fragments of native forest surrounding the plantations. As a result, many of today's plantations host high levels of native biodiversity, both plant and animal. And this presents a major challenge for forestry companies: how to manage these plantations using the typical harvesting method, in this case, clear cutting, while minimizing their impact on the biodiversity present within them or surrounding them. In addition, for certifying, these companies need restore the same surface of native forests that they replaced with exotic plantations. Well, on the other hand, since 1993, Chile has an environmental impact assessment system that requires companies of any kind to conduct assessments before carrying out development projects, such as mining, energy, highways, urban construction, and so on. Any project that could potentially alter natural ecosystems, whether already degraded or relatively intact, is legally required to conduct an environmental impact study. This process typically begins with what is called a baseline study, which includes both flora and fauna. And in both components, but especially in the flora component, many forestry engineers are currently employed to evaluate the flora and vegetation that may be or will be affected by development projects. They also play a key role in proposing various environmental compensation measures related to both flora and fauna. In summary, environmental assessment work involves first conducting a flora vegetation sampling to know the floristic composition and vegetation structure, and fauna sampling, especially of vertebrates, to know species composition and distribution of the animals present in the areas that will be affected by development projects. And many forest engineers are working in this type of job. Well, equally important is the creation of maps showing the different types of vegetation that will be impacted, as well as the extent of the affected areas. All of this is based on photo interpretation, remote sensing analysis, and the use of geographic information systems software to produce cartography and spatial surface analysis. Well, also as part of the legal requirements imposed by the Chilean state on companies that generate environmental impacts, there is an obligation to reforest the affected areas or other similar areas with the same type of forest and the same dominant species that were impacted by development projects. As a result, in recent years, the area of land reforested with native species has increased significantly, but not for productive purposes. However, these are plantations composed only of the main native tree species from the forests that were removed or affected. Therefore, they don't truly represent ecological restoration processes. For example, there's no requirement to reintroduce shrub, herbaceous, or animal species that were present in the original forest and probably eliminated during implementation. But still, at least the forested area itself is being recovered. However, only in the past 10 years or so, some scientific knowledge has been incorporated in this reforestation effort. In the late 90s and early 2000s, many reforestation efforts failed, sometimes significantly, because they were carried out without any scientific basis, especially in terms of a species selection and the application of appropriate reforestation techniques. Currently, one of the main institutions employing forestry engineers in Chile is the Forest Service. One of the areas where forestry engineers have traditionally worked in Chile is as administrators of protected areas. What is relatively new in this area is the significant increase in the number of private reserves in Chile, adding to the already extensive network of public national and state parks and reserves, where many forestry engineers are now also employed in management and overall administration. Within the Forest Service, there's also substantial work related to wildfire management, including fire prevention, control, and post-fire restoration. This is a very important unit within the Chilean Forest Service. Another unit within this same service is responsible for monitoring management plans. These are plans submitted by companies or private landowners, and they must be reviewed and monitored by the Forest Service. And finally, The Forest Service also includes a promotion unit focused on encouraging reforestation with either native or even exotic species, with the main goal of increasing forest cover throughout Chile. Well, in recent years, but I would say particularly over the past decade, the job market for forestry engineers in Chile has expanded in the area of urban vegetation management, especially in the field of urban forestry, urban silviculture. Historically, urban vegetation and street trees in Chile were established and managed without the application of scientific or technical knowledge. And as a result, urban trees were often unmanaged or at best occasionally pruned, but there was no technical planning involved. This has begun to change over the past 10 years. Although this progress has been slow, more technical and planned management of urban trees is increasingly being implemented, mainly under the responsibility of municipalities and some state institutions. Well, some forestry engineers also working in government institutions and ministers, particularly in land use planning processes, where they are involved in developing territorial management and planning strategies. Additionally, many forestry engineers run their own businesses. One of the most prominent areas currently is the production of seedlings for reforestation purposes, whether for restoration, or forest compensation, urban reforestation, or other objectives. This is a business likely to remain in demand, given the country's growing commitments to restoration, which require high supply of plant material, seedlings especially. And lastly, some forestry engineers also work in research, either in universities, at the National Forest Institute, or even in forestry companies that engage in research and development. Well, let's now move on to a description of forestry education in Chile. Currently, 5 universities in Chile offer undergraduate degrees in forestry engineering. However, from the late 90s to the early 2000s, a significantly higher number of universities offered forestry engineering programs, approximately twice. Around 2004 or 2005, there was a sharp decline in the number of students applying to study forestry engineering, and the main causes are related to the fact that up until the late 90s, the forestry sector in Chile was almost exclusively associated with the industrial forestry sector, based on exotic tree plantations. At that time, native forest silviculture was still minimal, especially with it came to companies managing native forests through planning rather than simple logging and harvesting. Additionally, the field of environmental impact assessment was only beginning to emerge in the late 90s and early 2000s. And as a result, most newly graduated forestry engineers typically found work only in the plantation-based forestry industry or occasionally in the National Forest Service. The number of forestry-related jobs was still quite limited in Chile. Moreover, forestry companies began to automate and apply new technologies to many stages and processes of forest management, which reduced the demand for forestry engineers, especially in the industrial sector, which increasingly required industrial engineers instead. All of this contributed to a shrinking job market for forestry engineers in the early 2000s. And this decline in job opportunities led to a reduced interest among high school students in studying forestry engineering, which ultimately resulted in some universities shutting down their forestry engineering programs. In fact, this low level of student interest persisted until just a few years ago. Well, currently there are also not many graduate programs in forestry engineering or forest sciences in general. Here I show 4 programs. These are from the same universities that offer undergraduate programs in forestry engineering, and also have doctoral programs in related sciences or that include forest sciences at least. But for example, as you can see here, only the University of Concepcion has a specific PhD program in forest sciences. The same applies to master programs. Only 3 universities have master programs related to or that may include forest sciences. For instance, at the university where I work, the Pontifical Catholic University of Chile, there's only a master in natural resources, which includes some or potentially can include forest-related topics if students are interested, especially for their thesis, which occurs, but very few in the area of silviculture compared to the area of conservation and restoration. And as you can also see here, only the University of Concepcion has a master program exclusively in forest sciences. Well, what is the forestry engineering program like at my university, the Pontifical Catholic University of Chile? Here I show you the graduate profile of the forestry engineer. The UC forestry engineer is a professional with a solid and up-to-date scientific and technological knowledge, enabling them to evaluate, plan, and manage productive activities, biodiversity conservation, and the restoration of forest and xerophytic ecosystems. They practice their profession ethically, innovatively, and efficiently with an ecosystem-based approach, whether in the public or private sector. They integrate physical, ecological, socio-cultural, legal, and economic dimensions with the goal of achieving sustainability in the generation of goods and services for both humanity and nature. Well, this is what we expect a newly graduated student of the program to be, and to include within their competencies as a forestry engineer. Here I'm showing the course program, the curriculum for the forestry engineering degree. different stages within the degree are shown in different colors. Our degree program at the university is organized into majors and minors, along with an initial plan that is shared with the agronomy program within the faculty. Here, for example, in green, we see some courses from the common or basic plan, which is shared with the agronomy program and includes basic science courses such as mathematics, chemistry, ecology, biochemistry, botany, plant physiology, genetics, statistics, economy. Then in a more reddish color, courses corresponding to general knowledge within the fields of both forestry engineering and agronomy are indicated. First, there's an introductory course on agriculture and forestry systems. Then there's a course with that teaches how to conduct scientific research. And finally, there are courses focused on project development and evaluation. In the yellow boxes, I'm showing the courses classified as general education courses, which are related to subjects outside the forestry engineering, such as theology, art, philosophy, history, among others. It's only in the second and third years of the program that students begin to take courses more specifically focused on forestry engineering itself. Here in blue, I'm showing the courses that make up what is called the forestry engineering major. Here are listed here these courses: forest ecology, geomatics, plant biodiversity, forest hydrology, native forest silviculture, biological conservation, environmental and natural resources economy, forest sampling dynamics, climatology, and soils and fertility. Then, these courses are taken during the second and third years. Then in pink here, during the fourth year, students take courses related to a minor. There's only one minor at this stage for forestry engineering students in our faculty. The required courses for this minor are forest management and planning, forest health, which is a course of entomology and pathology, and advanced silviculture, which is a course of nursery practices and reforestation. And then during the last year, other minors, one is called conservation and restoration, another territory and sustainability, and other elective courses. Well, several courses in the program include field activities, field trips that last 1 day, 2 days, or others lasting even 6 days. Here you can see various photos of students participating in practical activities throughout their courses. We try to incorporate as many field activities as possible, although it is always a challenge due to the codes and time required for these activities. Still, these field trips are likely where students learn the most, and they also really enjoy them. The students also have practical activities in the nursery and greenhouse of the faculty as part of some courses related to this work, as well as some laboratory work depending on the topic of each course. Well, currently, the number of students entering forestry engineering programs in Chile has remained relatively stable over the past 10 years. This represents the total number of students entering forestry engineering programs across Chile, with fluctuations of around 20 to 30 students, more or less. At our university, the Pontifical Catholic University of Chile, the number of incoming students has fortunately increasing over the past 14 or 15 years, especially since 2015. In recent years, the number of students entering the forestry engineering program has stabilized at around 20 and 30 per year. Nevertheless, here you can see the last years of the period of nearly 10 years since 2005, during which enrollment in forestry programs was quite low. In our case, around 5 to 7 students per year. The same trend was observed at several other universities. Well, some final conclusions. Well, we can highlight that Chile has a remarkable variety of ecosystems that are highly relevant to the practical work of forestry engineers and to the profession itself. On the other hand, forestry engineering in Chile is applied across a broad spectrum of topics and professional fields, each with different focused objectives and functions. This range from environmental impact assessment and consulting to forest conservation and restoration, and of course, everything related to the management and silviculture of native forests and exotic plantations, including the management of urban vegetation. Therefore, given these two defining characteristics, I mean, Chile's diverse ecosystems and the broad range of professional fields forestry engineers must be prepared for. Forestry education in Chile must integrate and address this diversity. It needs to prepare students to meet the wide range of functions and professional fields and teach them to work across the full spectrum of ecosystems where forestry activities are carried out in the country. I believe that forestry engineering programs around the world should train students to work in a wide variety of ecosystems of forestry interests and to perform a diverse range of tasks, from conducting environmental assessments and applying technical and scientific knowledge to conserve and restore ecosystems, to practicing silviculture and promoting the sustainable use of forests. And that's it. Thanks. Thank you very much.
Yeah, thank you very much for your kind and wonderful presentation. It's a huge presentation of 1 hour nearly. And this is the way actually came to know about the Chile and forest. Thank you very much, particularly for giving us enormous knowledge about Chilean forest. However, the audience have some questions. Maybe I have the privilege to start with that. Uh, please let me know that how the social system adopted over there for changing forestry practices. Particularly, I saw from your slides that once upon a time, Chile was very rich with forests, but now eh, the deforestation rate was very high. And is it human induced deforestation or the naturally it is declined? Please let me know. And I also ask the audience, if you want to make questions to Professor Dr. Pablo Becerra, uh, please raise your hand and go ahead. Thank you very much.
Well,
Dr. Pablo Becerra.
uh, well, the deforestation in Chile started probably before the European colonization of South America with the native people living in the country. But the knowledge about that is very poor. However, it's very we are sure that the main deforestation in terms of surface, in terms of area, started and increased with the European colonization, and even not from the beginning, but I would say that only since this the 17th century or 18th century, the area of the Chilean forest was started to be degraded and replaced by mainly agricultural objectives, and now the forest deforestation remains with development projects. Probably the magnitude, the area is smaller than or compared to 100 years ago, but the deforestation remains, and the problem, such as I said in my presentation, the problem is that the legal framework that there is in Chile doesn't ask for truly restoration programs. Only ask for reforestation of some tree species to compensate the forest area that is replaced for development projects, but they are not restoration programs at all. So on the other hand, there are many there are much area of forests in small landowners, small properties, and I mean of native forests, and the management of those native forests fragmented in different small properties is very difficult. So people living in rural areas needs wood, needs trees to different goals, but they don't manage the forest with technical knowledge. So the native forest in Chile is used today, but with very few or very or is not managed with scientific knowledge. Only some small big companies manage the native forest with silvicultural and techniques and scientific knowledge.
Thank you very much. Is there anybody? If floor is open, if you have any question, please ask him. Dr. Suji, please.
Yeah, thank you, Professor Becerra, for the interesting presentation. So I have like I think it's a simple question regarding to the like the consulting companies for the first assessment you showed us. I want to know like is it like a job with decent payments from these companies, and if like the students like can students undergraduate students enter these companies after their graduation?
Forestry companies?
Yeah, like the consulting service companies. Yeah.
Yes.
Yeah.
Yes, I would say that currently only few students in general in Chile, not only in my university, only few students enter to work into big forestry companies because these companies don't have many opportunities for jobs. Currently, the main source of work for forestry students, for graduate students, undergraduate students, is in environmental assessment, environmental impact assessment by consulting. Well, this area is also operates by through companies, but they are companies focused on the environmental impact assessment.
Okay. Yeah. Thank you.
So thank you very much. Is there anybody interested to make a question to Professor Dr. Pablo Becerra? Okay, it seems that everybody got their all questions answered in his presentation. This is a wonderful opportunity for us to know about the Chilean forestry activity from the very primitive era to date, and as well the forestry education program. We are heartfelt thanks to Professor Dr. Pablo Becerra for his wonderful presentation to us from the developed to developing nations with this platform of Asia Pacific coordinated mechanisms of forestry coordinated mechanism, APFESM. And we also thank to Dr. Suji for coordinating all the programs very nicely, and all the participants, those who giving their valuable time for getting this knowledge, and this program became successful. Thank you very much. Thank you to you all. Dr. Suji, please.
Thanks you.
Thank you. Thank you,
Thank you very much.
everyone. Okay.
Goodbye.
Bye-bye.
Goodbye.
Have a
Thank you.
good evening, good morning, everyone.
Nice to meet
Yes.
you.
Nice to meet you all as well. Thank you.